Welcome to an ongoing episode, if you will, of the Phil Simon Clinic speaker series. And I just wanted to show a few things that are up and coming here. We're actually having another special speaker next week. This is sort of two of them together here. So this is Dr. John Texas, who is the acting dean of the School of Veterinary Medicine at Western University, and very prestigious place to train as a veterinarian. He is going to give a discussion on snake bites and envenomation, a very big global problem, especially in underserved countries. And we certainly see patients with this kind of problem in Tanzania. I remember when a woman came into our clinic out in the Serengeti that she had been sprayed by a cobra. So snake bite and snake spray, I suppose, are both things that maybe we don't worry about too much, but it's certainly a worldwide problem. So we're looking forward to having Dr. Texas next week at 7 o'clock on the 14th. That's a Thursday, not a Wednesday. In October, we have Dr. Aaron Berkowitz, professor of neurology at UCSF. He's going to discuss his book, One by One by One, Making a Small Difference Amid a Billion Problems. Dr. Berkowitz has spent a lot of time in underserved countries, especially Haiti, where he worked with the very famous Paul Farmer and Partners in Health. And he's going to share his experience working for underserved communities globally. So it's a very relevant topic for our own project. And then finally, a little bit of fun. We're going to be doing a live speaker series. If you are local, or even if you're not, you want to travel to beautiful Pasadena, we'll be doing a live speaker series, a summary of our year events and our scholarship program at the La Casita del Arroyo, which is a beautiful historic venue in Pasadena, right on the Arroyo Seco. And it's going to be a live speaker series for about 20 to 30 minutes. And then we're going to have hors d'oeuvres, wine, and a wonderful art market where you can purchase original art by many members of our board and supporters of our program. And also there'll be quite a few beautiful art pieces that have been brought in from East Africa. So if you'd like to buy tickets to that, you can go on the QR code or go on our website, philsimontanzania.org. And we encourage you to attend. It's going to be from 3:30 to 7. Lovely way to start the holiday season. You can probably pick up some unusual gifts for your family for Christmas or Hanukkah or any other holiday, and we hope to see you there. So without further ado, I will go ahead and begin our lecture. I thought it would be helpful to do an update on the COVID situation and vaccinations in general on the eve of the FDA's approval, the FDA and the ACIP's approval of a new booster for COVID-19. So, but this discussion will be about other viruses as well that we have to contend with, and vaccination in general. So human beings have been plagued, shall we say, by pandemics for most of our existence. But there's been some very interesting developments in sort of the evolution of infectious diseases in conjunction with the human species. And a way of looking at it is through paleogenomics, where we're looking at old genes from people that lived many years ago. There's a recent study that was published in Nature that looked at the presence of DNA in individuals that were exhumed from some graves that were discovered in England that dated back to the 1300s, and when the Black Plague was circulating. And scientists were able to analyze the DNA of these individuals who had succumbed to plague and discovered that they had certain genetic markers. What's very interesting is that some of these pathogens really sort of then imprint on the human genome, and then those markers are carried on to the next generation. So when we look back, we can see the effects of different kinds of pathogens, viruses, bacteria, and other events that happen to our species through evolution. Interestingly enough also is that many of these pathogens leave their mark in areas that eventually become associated with autoimmune diseases. And so this article that was actually published in the Washington Post talked about sort of the double-edged sword that individuals that we benefited from the sacrifice, if you will, of individuals who died from these diseases during plagues and pandemics and their genes eventually provided protection, immunity to those particular pathogens. But in the course of that, they also increased the risk of autoimmune diseases, which are basically more of a more recent event in human evolution. So it's a very interesting area that's being explored deeply with some of the genetic capabilities that we now have. And to this point, it's thought that actually infectious diseases, though they were certainly common throughout the evolution of human beings, they really didn't become sort of pandemic until human beings started to living together in villages. So, for example, Cro-Magnon, who's this gentleman here, this is at the Les Izzy Museum in the Neolithic Museum in France in Les Izzy. These individuals, although they may have had infections, they didn't live in large communities, and so the prospect of a pandemic was much less. By the Bronze Age, two things happened. The wheel began to emerge as an important mode of transportation. People began to migrate, but they also began to come together and switch from a hunting-gathering sort of subsistence to agriculture and animals. And that contact with animals, close contact with animals and living together allowed the spread of bacteria and viruses very quickly. And that really was sort of the beginning, if you will, of the pandemic era for human beings. So we are all very experienced now. For the last 3.5 years, we're living through another pandemic. And I think what's happened since the 1950s, it's been, we've had a relatively quiet period when it comes to pandemics. Pandemics have been a very important part of history of human civilization. And in fact, they've changed governments and really had a great impact on how we evolved. And they were very, very common. It really was very common even by 1900 that individuals would succumb to infectious diseases. They spread quickly around the world. And though we did have some early vaccines, it wasn't really until the 1950s that we began to develop ways of preventing infection. And of course, then with the advent of antibiotics, ways of treating infection. But it will be interesting to see what the mark of SARS-CoV-2 is on our history as a species, because it so happens that SARS-CoV-2, the virus that causes COVID-19, is an extremely immunogenic, immune-stimulating virus. It likes to attack the immune system. The immune system is trying to fight it off. And the virus certainly stimulates the immune system, but also can sort of take the immune system hostage and lead to either a bad outcome if you get very serious COVID, or immunity, which is what we hope most people would happen if they became infected, or unfortunately some unusual and very mysterious diseases such as long COVID, which we still don't really understand all of the pathophysiology. So it will be very interesting to see what the human genetic legacy of COVID-19 will be over the next hundreds of years. It's likely to make sort of a permanent impression, if you will, in our genome, and it certainly has made a very big impression in all of us who've lived through it. But it was about time for us to have a pandemic. The other thing I sort of want to make clear is that pandemics can overlap. It's not like when you get through one pandemic and then the next one, and you have a little break before the next one comes along. That isn't usually the way it works. It's just very happenstance. And I think that what's happening globally with climate change and with the increase in human population and the global migrations of people and movements, the ease with which you can move around the planet, our encroachment on wild areas and so forth, and has really increased the risk for genetic events, genetic spillover events that will cause other pathogens. We're watching very carefully for the emergence of a more resistant influenza. The H5N1 variant seems to be spreading quite quickly right now in markets in Finland where they raise mink. And it's been something that we're watching very carefully to make sure that that does not jump into human populations, because it could be another type of very serious viral pandemic. But let's talk a little bit.
Kim,
yes.
Can you share your screen, because your slides are very small?
Oh, I am sharing the screen. Can you see? You don't see the whole screen?
You can change to the speaker
No,
view.
I see the whole screen.
Yeah.
Okay, I guess it's me.
Yeah, I can see the whole screen.
Okay, put on your glasses, Jody.
I can't see him. This is Esme.
You can't.
I just see you.
Okay. Well, let's see. That's going to be a problem. You want to reboot?
No, people can change the way their display is displaying.
Okay.
Person can customize it for their Zoom. So Kim, you were doing
Okay.
great with what you had just now before.
Okay. All right. I guess you're on your own, folks. I'll try to describe the slides as well as I can.
Now I
So-
see it.
Okay. All right. We're good. Thank you for telling me. But resuming our story, vaccines are really one of the best ideas ever. And I will talk a little bit about why that is in terms of the remarkable things that they've achieved. And now I've got to get to the vaccination actually is something that's been going on for a very long time. There's lots of especially with diseases like smallpox, there's lots of documentation of sort of vaccine ideas that were early in China and India. And in fact, it was recognized that individuals that had perhaps a mild case of smallpox, that they never got it again. And that was an observation that many of these individuals during those times recognized. And so they would take a little scraping from a smallpox pustule and inoculate it in somebody else. That would give them smallpox, of course, but then if they didn't die from it, they would develop immunity. And that was identified very early in these cultures. There was a very famous woman named Lady Mary Wortley Montagu who traveled and spent a great deal of time in Turkey. And when she would go to the Turkish baths, she noticed that the women in Turkey did not have the terrible scars that she saw in women in England. And this was because of the process of variolation, which is exactly what I described, where you take a little bit of crust and inoculate it, and that induces a milder form of the disease, hopefully, and produces immunity. The term vaccination came from vaca, or cow, and that was in relation to Edward Jenner, who was largely given credit for the emergence of vaccination and the acceptance of it in Europe, but it really was Lady Montagu who was described as a quote unquote ignorant woman. But she turned out to be, of course, very prescient. And many years before Jenner thought of the idea, she had recognized the importance of a small amount of disease to induce immunity. Be that as it may, Dr. Jenner noticed that milkmaids in England did not develop smallpox. And so he was able to conclude that, although at that point the germ theory had not been developed, that there was something similar between cowpox and smallpox. And so he decided this was definitely not a HIPAA-approved or IRB-approved research project. He used one of his maids, his gardener's son, some little kid named James Phipps, and scraped some cowpox crust from one of the milkmaids and inoculated his arm. And then the kid was allowed to play with other children, and he never developed smallpox. And that really was the first recognition that that kind of process could protect you and prevent disease. Pasteur took this to a whole nother level with his experiments with rabies, and they were even perhaps more draconian in that there was no human intervention approvals for any of this experimentation, but he did prove that rabies vaccine could be developed and that it was highly protective against what continues to be actually to this day a very difficult disease to treat once it happens. So after the advent of this recognition, the vaccine idea really took hold in the world of science. But there was this long period between the discovery from Jenner all the way up, really, frankly, into the early 1900s, where nothing much happened except the idea that you could inoculate people with small amounts of whatever the pathogen was and induce some immunity. But it was dangerous. Many of these people died from reactions or from impurities that were in the inoculation. The 1950s was when the race for the polio vaccine happened, and that really changed everything. And that was one of the first widely effective vaccines that really prevented a devastating disease. Many of you, if you have parents that are still alive, they have memories, of course, of people with polio. My mom's 92, and she remembers lots of kids that had polio. It was really a devastating disease. And so the advent of a very effective vaccine just was a tremendous development in medicine. And since that time, we've really developed amazing vaccines and relatively quickly, perhaps most recently culminating in the advent of the vaccines for SARS-CoV-2 that occurred within a very short period of time after the emergence of a brand new pathogen. It was really thanks to a lot of the knowledge that we had from all these other events that led us to that discovery. So what's the benefit of vaccines? Well, they prevent disease and death in individuals and in populations. They have saved millions and millions and millions of lives since the inception of vaccination. you can eradicate significant threats to humanity. Smallpox has long been a scourge in the human species, and vaccines have really effectively eradicated it from the planet. It's only known to be in small areas where there's bioterrorist banks, if you will, but it's been eradicated basically from the planet in humans as a natural pathogen. That, of course, then confers significant economic benefits and sociopolitical stability by preventing diseases and pandemics. Pandemics have a way of kind of nurturing unrest in society, as we perhaps have seen recently. Occasionally, it can lead to the fall of significant societies. That's probably what happened with Rome when a very bad smallpox pandemic occurred at the time of Marcus Aurelius. It gives us an understanding of pathogens and how they produce disease. And we've been able to identify pathogens, of course, since the advent of many of the discoveries in science and the germ theory. We have an improved understanding of immunity and immune modulation, the activity of the immune system. But I will tell you that the more we learn about the immune system in humans, the more complicated it is, and really the realization that we still don't know very much about it. Vaccination has promoted and advanced technology, science, and medicine. Of course, it prevents infectious diseases. There are many vaccines now that help prevent cancer. The human papillomavirus vaccine, of course, is a big one. Big problem in young women and young men. Squamous cell cancer and HPV vaccine is highly protective against that and prevents a huge number of disease and death in individuals. We can use vaccines as treatment. The Ebola vaccine now is out this is for the Ebola Zaire variant, and it works as a treatment. And of course, vaccines can change the course of history, as they have done. So they're very, very important medical events. Just to sort of give you an idea what the global impact of vaccines can be on childhood mortality, in 1990, there were 93 of 1,000 live births globally where children died of preventable diseases. And happily, in 2018, that number has dropped significantly. We, of course, would like to see that number to be 0, but it is down to 39. And that's in large part due to the widespread use of polio vaccine and other vaccines for diarrheal diseases. And of course, now the advent of a new malaria vaccine, which could save millions and millions of children's lives, especially in continents such as Africa. WHO estimates that 2 to 3 million lives are saved each year by robust immunization programs. And we have, as I mentioned, really almost eradicated polio from the planet, but we certainly have with smallpox. So what is a vaccine? Well, it's a substance that through inoculation, ingestion, or inhalation stimulates the immune system to fight off infection from specific pathogens, such as viruses, bacteria, and parasites. That's sort of the simplest idea of what a vaccine is. There are many different types of vaccines now that we have. The older type vaccines were live attenuated vaccines, where you take the pathogen and you kind of make it a little bit less nasty. That's kind of what Jenner was doing with the cowpox. The early vaccines were live attenuated vaccines. They did have some significant side effects when you do a live vaccine. And of course, there's risk of disease with the pathogen. So you have to be very careful. Killed whole vaccines or organisms are still part of vaccines that we use today, including the pertussis vaccine. You can make vaccines against the toxins that bacteria produce, such as diphtheria and Clostridium tetani, the Clostridium tetanus toxin. This purified protein subunit recombinant vaccines are very common. This is what the Novavax vaccine for COVID now is used. They use a subunit protein vaccine. We use this with hepatitis B and some of the pneumococcal vaccines that are out. You can use a virus that imitates the virus that you're going against. This is how the papillomavirus vaccine, HPV, is made. And then you can use various proteins and different vectors to carry the virus and parts of those proteins in to stimulate the immune system to protect you from whatever organism you're trying to protect from. That's kind of what we do with the Ebola vaccine. Of course, in 2020, we deployed the very first mRNA vaccines, in which a small bit of RNA from the virus is designed to be in the in the main part of the vaccine. It'll stimulate immunity to a specific part of the vaccine. In the case of SARS-CoV-2, it's the spike protein, and that was a huge development. a lot of people think, well, this vaccine is a very new vaccine. The technology for mRNA vaccination is not new. mRNA technology has taken about 25 years to develop, also started basically by a woman, Katalin Kariko. But so it was ready to be deployed. It's just we didn't have a sort of good reason to do it. And there's nothing like a big giant pandemic with a respiratory virus that will allow you to test the efficacy of a vaccine very quickly. So within about 3 days after the Chinese released the genome for SARS-CoV-2, NIH began to work on an mRNA vaccine in conjunction with Pfizer and Moderna. And the vaccines were deployed after studying 40,000 people in each group. That's a very large study. Most vaccines have been approved with far lower numbers because it's hard to accrue that many subjects. But when you have a pandemic, you got lots of people with the disease. And of course, the efficacy of the vaccine has proven to be very helpful. It is important to understand that many times vaccines are really not designed to prevent disease. They prevent serious complications from the disease and hopefully prevent death, but they don't always prevent infection. And I think that's been something that many folks have been kind of disappointed with the COVID vaccines, that you can still get COVID even though you're fully vaccinated, but at least you're not going to the hospital, you're not on a ventilator, and hopefully you're not dying from the disease itself. So that's really what vaccines are designed to do, is to prevent serious illness. The immune response to vaccines is very complicated, and we still don't understand a lot of parts of it. Suffice it to say that when you get the vaccine, it tells the immune system to do something. And the first response are what we call neutralizing antibodies. Those are antibodies, they're very nonspecific. They just go, ooh, this isn't myself, and I'm going to make these special molecules that grab this, whatever this is that I'm dealing with, and try to isolate it and then basically inactivate it. So that's the first response that you get after inoculation. The second response is the memory, where the immune system takes this information from the antigen, that's the information part of the vaccine, or the bacteria or virus that you're infected with, and stores it in the memory in your what are called T cells. And those then can go back and stimulate the B cells to make more antibodies should you encounter the real virus or the real bacteria, or you get another vaccine. And that's why when you get a booster shot with COVID, the COVID vaccines, you sometimes have a little reaction. That's your immune system responding that, oh, I recognize that. That's SARS-CoV-2 spike protein, so I'm going to make some more antibodies and go after it. So that's sort of a general overview of how the immune system responds. It's much, much more complicated than that, but it is sort of the essence of it. So let's sort of get to the crux of the matter. Everybody sort of wants to know, what kind of vaccines should I get? And that's a very important consideration, because we have so many to choose from, it can be very confusing. So that's sort of the point of this discussion, is to kind of go through this. This is the CDC's table on recommended vaccinations for adults. There's a few things that overlap, of course, with children, but I won't go into children too much at this talk. And what you see, whether you see the yellow, this really basically is everybody should get these vaccines. So you see for COVID-19, we recommend that you have the 2-part prime series, where you get the first shot and then you get a booster. And then that's what we all did back in January of 2021. And then you get a booster semi-annually, every 6 months, or annually. We think that probably the COVID-19 boosters are going to move into more of an annual indication, but we don't know for sure. Now, there are probably very few people on the planet that have either not been vaccinated or have not had the disease. There's plenty of people who haven't been vaccinated, but chances are they've probably already had COVID at some point. So we're not doing the 2-part prime and boost at this point. We're just giving the boosters and then sort of seeing how they do. But we'll talk a little bit more about that in a second. Influenza, of course, we do recommend an annual influenza shot, and I'll talk about that in detail as we get through that. We recommend that people stay up to date on their tetanus, diphtheria, and pertussis. These are still significant diseases, especially pertussis. Not so much diphtheria, although we are seeing an increase in diphtheria in areas that are undergoing a lot of political unrest, where there's a lot of migration of people moving into refugee camps and so forth. That tends to be a disease we see there. Tetanus is still around the planet and still can cause death. It's a very bad disease. So we do think that people should stay up on their Tdap. Measles, mumps, and rubella, of course, we certainly want people to be vaccinated against these very highly infectious and often very dangerous viruses. Varicella, the virus that causes chickenpox, If you have not had chickenpox, we recommend that you get a varicella vaccine. And then, of course, Shingrix or the varicella shingles vaccine, which we recommend now for all adults. And I'll talk about that a little bit later. Human papillomavirus for both boys and girls in young ages to prevent HPV-associated genital cancers. The pneumococcal vaccine, hepatitis A, of course. All these vaccines are routinely given to young people. We tend to give meningococcal vaccines for college students or Army recruits because that's something we see where it spreads in congregate living situations. And the Haemophilus vaccine has really almost eradicated Haemophilus influenzae from pediatric pneumonias and so forth. It's a very important vaccine. It's been around for a while, but people sort of forget about it sometimes. So let's talk about COVID first. I will tell you that we are in the midst of, somebody once called it a surgelet. It's not exactly an enormous wave of COVID, but we're seeing plenty of it, and we're still in it right now. We have about 30 patients in the hospital right now that are hospitalized with COVID, and that is reflected throughout California and actually the rest of the country, and probably pretty much globally. This is a function of a couple of things. Waning immunity. People's last time they got a vaccine was probably last fall, unless they've had COVID since then. And also everybody's out enjoying the summer and not wearing masks. There's not a lot of mask wearing going on. And so that really allows the virus to take advantage of that situation. And that's what we're seeing, especially now. We may get another little further uptick in the number of cases and hospitalizations and because of Labor Day. We're a little bit handicapped now, unlike last year, where we could add a lot of public testing so we could really keep track of what was happening around the world in terms of cases. But now we're sort of stuck with having to look at hospitalized patients or people who come to the emergency room, which is, unfortunately, the horse is already out of the barn by that time because that means people are sick. That really has no way of knowing who's out there that isn't that sick, that doesn't require coming to the hospital. And many people are testing at home, so we just don't know the number of positive tests. The other thing that we can do is to look at wastewater. And this has actually become a very interesting and very important technology. You don't have to do it just for infectious diseases. You can do it for things besides COVID. You can do it for methamphetamines to see if a community has a high incidence of drug use. So it's actually become a very important part of assessing kind of what's happening in a community from an epidemiologic and disease standpoint. And it matches pretty well with surges that we see. So if these are the wastewater analytics here, where we go in and they sample the wastewater, they look for genetic markers associated with SARS-CoV-2, that does seem to mirror the clinical cases pretty well. When the wastewater starts going up, we start seeing more clinical disease. And so it is a reasonably helpful way to predict when something's going to happen, but it doesn't give you very much of a time frame. It kind of happens at the same time. The other problem is that sometimes other animals, of course, can have SARS-CoV-2, and that can be detected in this wastewater. There's no way we know that this is human SARS-CoV-2, so that can be misleading sometimes. But it's at least one way of saying, hey, something's happening. And as of July, we started seeing this uptick where in the wastewater in LA County, we started seeing more cases of SARS-CoV-2. Pasadena does not do wastewater analysis, but LA County does. And so that's very helpful to follow that. This sort of shows, again, what's happened over the last 6 months. We had this kind of high level back in March of last year, and then it decreased sort of slowly over the summer. We had a few little blips here and there associated with different surges, reached kind of a nadir, a low point here in July, and then just started going up. Now, some people appear to have peaked and gone over the top. We're still kind of on an upward trend. The West Coast seems to be having a little bit more disease than perhaps some of the other East Coast areas. But of course, as it gets colder and people start moving back indoors, we may see more of an uptick then on the East Coast. And this is LA County that shows what's going on here. We sort of reached this plateau, I think, a little bit. We kind of stay on that plateau for a bit and then it drops off. But it's sort of one way of trying to sort of figure out what's going to happen. Well, the virus is taking advantage of this. As I mentioned, a lot of open faces, no masks, and not as much immunity as we'd like. It's normal for viruses to try to avoid the pressures on them, such as vaccines or medications, and to develop new variations of themselves that are either more infectious, more virulent, in other words, nastier, can cause worse disease, or both. Right now, we still seem to be very much in the Omicron family. It's kind of a dynasty of viruses, if you will. Omicron has really traded in mostly for infectiousness, not for virulence, with the exception of early on when nobody had any immunity. We saw a lot of very serious illnesses with the Omicron variant as it first emerged. But it just keeps sort of morphing into new varieties, and it's kind of hard to keep up with all the different letters and names and so forth. Right now, we predominantly have XBB variants. Again, they're all part of the Omicron family. This EG5 seems to be kind of becoming a little bit more prominent. They all kind of duke it out in terms of who's going to be the best virus to be most infectious and infect people. What we don't want to have happen is a variant that emerges that is highly evasive of the vaccines and or the antivirals that we have. That would be a very serious situation. There isn't a whole lot we can do to prevent that from happening, except trying to keep the amount of disease that's circulating down as much as we can, and treating people very quickly so that the virus just doesn't have a chance to keep replicating and producing mutations that will be helpful for it. Again, this is wastewater detection of the different variants. This was the Delta variant. That was a very serious variant, highly infectious, also highly lethal. It had a lot of very serious illness with that, but thankfully it was relatively short-lived. It actually serves a virus better for a host to live longer, because then they can spread more virus to other people. If the host gets sick and has to go to the hospital and sort of is out of commission, that doesn't serve the virus well. If the host dies, that doesn't serve the virus well. But if the host continues to feel, maybe a little bit punk, but still can go around, they can spread the virus. And that's what seems to have happened with the Omicron family. These are some of the newer variants here that are beginning to emerge right now. Genomics are done not with as much frequency and accuracy as I shouldn't say that's quite accurate, but not with as much frequency as we had earlier. So we do have to kind of rely on regional areas and what's circulating. So what is the threat of the new variants? Well, as I mentioned, Omicron is a viral dynasty, and all of the current variants are derivatives of Omicron. There is a large amount of immune experience around the world. Most people have either been vaccinated, had the disease, or both. There are probably a few people who have not had either, but that's rare. And so the virus really is kind of bumping up against a lot of immunity, and that makes it perhaps want to develop some mutations that can improve its fitness. It's those external pressures of vaccination and immunity in the population the virus tries to avoid. However, at this point, it does appear that SARS-CoV-2 continues to favor infectiousness over virulence, and that the vaccines continue to offer very, very good protection from serious illness and hospitalization, though not from infection itself. We are keeping a very close eye on this variant, the BA 2.86. It has been designated a variant of interest, or not necessarily a variant of concern by the WHO. It's been identified in Switzerland, Denmark, the United States. There's been a few cases, and a couple cases in Asia. And what's concerning about it is this diagram down here. This is from Eric Topol, and you can see the number of mutations that the BA 2.86, which is for some reason called pyrola, has. It has about 30 to 33 mutations, largely in the spike protein. And that makes it perhaps more immune evasive. Whether it will become a dominant variant, we don't know yet, but it's something we have to watch very carefully, because this happens very quickly. And so as we are ready to deploy a new variant-specific vaccine, we already have some evolution of the virus, and it's sort of catch up all the time, which is a problem in the world of developing vaccines. So as you may have heard, the XBB variant monovalent vaccine has been developed by both Pfizer, Moderna, and Novavax. The Novavax monovalent XBB variant is a subunit protein vaccine. Moderna and Pfizer have the mRNA vaccines. But they probably will be released the middle of next month. They actually were approved and studied quite well at the beginning of the summer, but there's been sort of some slow movement through the FDA and the Advisory Council on Immunization Practices, the ACIP, because of some concern about recommendations for younger people. Suffice it to say that it should be deployed by the middle of September, the end of September. It is a monovalent vaccine. It only has one variant in it, as opposed to the BA.4/5, which was the bivalent vaccine. But it does seem to have immunity, or provide immunity to the current big circulating viruses such as the XBBs and the EG5. Moderna has some data that shows that it's quite effective against those. Whether it will be effective against the 2.86, we don't know yet, but we'll watch and see what happens. So the durability of COVID vaccination, that we know that the antibodies begin to decline after 3 to 5 months from the last immunization, but they still retain protective advantages for some time, especially from serious illness and death. It's likely that COVID vaccination will become an annual event, although it's not exactly clear what the COVID season is. It usually sort of follows when people get together. So we often have a season in the summer, at the end of summer, like we're experiencing now. We certainly have it during the winter. That tends to be much more robust. But it can be influenced by other events, large super spreaders and so forth. And the vaccinations will be adjusted as much as possible to the emerging variants, much like we do with influenza. It's actually quite easy to change the recipe on mRNA vaccines to match what you think is going to be the most important variant, but it is a little bit of a guessing game, as it is with influenza as well. So which and when should I get a COVID booster? If you're older than 65 or you're immunocompromised, and if your last COVID vaccine was greater than 6 months ago, this summer, you might have considered the BA.4/5 and then get the XBB in 3 to 4 months. However, as this vaccine is about ready to be deployed, the XBB booster, I would say at this point, I would recommend that you wait until that vaccine is out, which hopefully will be mid-September or the end of this month, and that's the vaccine booster that you get. You don't want to stack the boosters too much. They're not going to be, other than making it kind of unpleasant, so it's just probably not a good idea to get them too close together. If you've had a BA.4/5 within 6 months, you can wait for the booster to come out, as I said. And it doesn't matter which one you get. If you've had Pfizer, you can have Moderna. If you had Moderna, you can have Pfizer. And if you've had either one of them, you can have Novavax. They all have the same information for your immune system. So at this point, I probably would say there's no need for getting a BA.4/5 at this point. You should just wait until the XBB booster is available. And it should be widely deployed. I believe Pfizer is the first one out of the gate, and it's supposed to be at all pharmacies. If you're between the ages of 2 and 65, this vaccine is probably going to be likely annually. Again, those individuals, I'd wait for the XBB booster, but it's probably been more than 6 months for them as well. And it doesn't matter which vaccine you get. Some people sort of like to stay in the same family. Doesn't make too much of a difference. But I think that this booster will likely be very protective as we move into the highest season for COVID, which is, of course, the winter. So I'd highly recommend that you get that if you haven't had a vaccine or the disease within the last 6 months. Because of all this need to change the vaccine recipe, if you will, we do need to have a pan-coronavirus vaccine, a vaccine that's targeted against a highly conserved part of the virus and not the spike protein, which is the area that the virus constantly is changing. That is being worked on. We also need to have vaccines that can prevent infection. And that is also being worked on. We're looking at vaccines that can be given intranasally. That's the portal of entry, if you will, for coronaviruses in through the nose. So vaccines that induce immunity locally in the nose may be highly protective against infection. That would be an enormous game changer for all of us if we could prevent that. But it still is in a process and not quite available yet. Influenza tends to be more of an annual type infection. It's usually in the winter time when people move indoors. So in the southern hemisphere, it occurs in our summer months. In the northern hemisphere, of course, it's in the winter months. The vaccine is adjusted for circulating strains of influenza through the GISRS, the Global Influenza Surveillance and Response Systems. And it's a little bit of a best guess, but they always kind of throw in a few other bad players, such as H1N1, to make sure that people are covered for that. Right now, it looks like the current influenza vaccine is probably a pretty good guess. There seems to be not too much circulating in the southern hemisphere, and it's already been deployed down there. But sometimes we have a surprise even mid-season, and then they have to go and then change the influenza vaccine. There's 2 types of influenza. A is the more serious one, but B can be serious. The influenza vaccine is directed towards, again, surface proteins on the virus, the neuraminidase and hemagglutinin surface proteins. That's only relevant when you talk about the name for influenza in terms of how what they call it. But influenza, like COVID, evolves. And so the 1918 strain of the H1N1, which is probably what the cause was for that pandemic, we still have today. It's just a little bit different. And again, it mutates and evolves, becomes more infectious. And so we have to change the vaccine each year. And this is what the current vaccine is for this year. It has a hodgepodge of different things to try to make sure that the A and Bs are covered, including H1N1, which is probably the worst kind of influenza that we usually see. So we hope that this will be a good match, because influenza still kills about 50,000 Americans every year. It's still a very serious virus. Comes in different strengths. The trivalent was sort of one of the earlier ones. We really kind of recommend for most individuals to get the quadrivalent now, and that's basically anybody 6 months and older should get a flu shot. We have the high dose flu vaccine that we recommend for older adults. That has 4 times the dose, gives you a little bit more oomph to kind of for your immune system. And so that would be a high dose quadrivalent vaccine. For those that are allergic to eggs, there's a recombinant vaccine that you can use. The live attenuated vaccine is very good for kids. We don't use it too much in adults, and it does cause viremia. So you don't want to use it in a household where somebody is immunocompromised, because they could actually get the flu from the other person who gets the vaccine. A flu vaccine is made by many different pharmacy companies. There doesn't appear to be a shortage of flu vaccine. We had that a few years ago. And again, the quadrivalent high dose for individuals who are older than 65, and the quadrivalent for those under is probably the best recommendation. The pneumonia shot. One thing I always hear patients say, well, how could I have pneumonia because I got the pneumonia shot? Well, the pneumonia shot is pneumococcus pneumonia. It's the only one kind of pneumonia from a bacteria called Streptococcus pneumoniae. Still a very bad bacteria that can cause very serious pneumonias in anybody, especially immunocompromised and older adults. We have some very effective vaccines. The PCV20 is a conjugated vaccine. It's very immunogenic. It's the newest vaccine. It's probably really the one that we're going to use going forward in everybody. Many people have received the PCV13 and the PPS23, which this one's more immunogenic. This one has more varieties of pneumococcus in it. But suffice it to say that now, if you've never been vaccinated with pneumococcus, you want to get a PCV20, and we recommend it for everybody older than 65 to get the vaccine, or even early. Especially if you have an immunocompromised condition, then you should get it earlier. And so it's important in a lot of different types of cancer and so forth, if you're younger than 65. I want to mention RSV because we've made some really important changes this year and discoveries. It's a very significant virus. You heard probably a lot about it last winter when we had so many kids that were affected with RSV because they didn't have any immunity. But now we have 2 very effective vaccines and some potential treatments for young babies with RSV. It's an orthopneumovirus. It's sort of a common cold, but it can be very serious in very young children and older adults. Reinfection is common. It also has a seasonality to it. That was the dreaded tripledemic, was influenza, RSV, and SARS-CoV-2. It can cause pneumonia and is associated with an increased mortality in immunocompromised individuals. So the 2 vaccines, Glaxo has produced Arexvy, and Abrevso is Pfizer's vaccine. They are protein subunit vaccines. Abrevso was just approved for pregnant women in their 3rd trimester. And that's actually important for them to get, because then they will have appropriate antibodies for their brand new baby when they're born a few months after they've been vaccinated, because their antibodies will be circulating. We don't have a vaccine for children, but we do have monoclonal antibody protection. So very young children who present with RSV pneumonia or severe illness can get nirsevimab, which is a monoclonal antibody that's been approved now. And there's a second one, pavlivizumab, which was approved a little bit earlier. These are very effective at interrupting the disease process in young children who have RSV. I want to take a brief moment and discuss my favorite topic, masks. So masks are cheap, they're easy, everybody knows how to use them now, they're widely available, and they are very, very effective at preventing many respiratory illnesses. Surgical masks look better on people, they're a lot more comfortable, but they're not very protective. So if you're going to go into a high-risk area, then you probably want to wear a better fitting mask, such as a KN95 or an N95. Surgical masks have all these openings and flaps where the droplets can get in and out. So they're really not a good mask to use in high-risk situations, or if you're a high-risk individual, perhaps with an immunocompromised disorder, and you're going to a Taylor Swift concert. That's where you might want to wear a very effective mask, even though that's outdoors. This is just blanked on whatever this kind of study is called. But anyway, it's where we have infrared. There we go. looking at different kinds of masks. This is a surgical mask, and you can see that there's a lot of leakage around the sites of the surgical mask, whereas an N95 has a much tighter fit, and you don't see the spread of the virus going in and out. So reusable masks also have a lot of leakage, even though you can kind of be more stylish with the cloth mask, but you really want to stick with KN95s or N95s if you're in a high-risk situation. And again, everybody knows how to use them. And so go to the market, pop one on. You don't want to have to get COVID at Stater Brothers. That's not, you can get other good things at Stater Brothers, but not COVID, hopefully. So other important vaccinations for adults. Human papillomavirus for some individuals helps prevent squamous cell cancers, hepatitis A and B. Again, if you haven't been vaccinated for that, you can check your immunity. The zoster vaccines are very effective. A lot of people have kind of significant side effects with Shingrix. It's a two-part vaccine, but it is protective against shingles. It isn't absolutely protective. Some people can still get shingles. We have seen Mpox, which is in the same family as smallpox. So certain populations, it's appropriate to make sure that people are protected if we have an Mpox outbreak. Thankfully, we didn't have a really big outbreak that happened several months ago, but the vaccine is quite effective. And of course, I mentioned tetanus, diphtheria. Pertussis is a significant illness, and especially in adults, and kind of underdiagnosed. So that's something that you can get a shot and really protect yourself from that. There, of course, are many vaccines for travelers. I often have people ask me what kind of shots they should get when they travel to more exotic areas, and typhoid, of course, certainly is one of them. We want them to be up in their DPT. If you're going to be around animals or doing anything with animals, or you're a jogger in countries where there's lots of dogs that are running loose, you might want to get vaccinated against rabies. Yellow fever vaccine is a live attenuated vaccine. It's got some significant side effects, but is required to enter in some countries, and there are frequent outbreaks of yellow fever in South America and Southeast Asia. So again, those are certainly things you might want to consider. We really have to make sure that vaccines are equitably distributed around the world. And we also have to develop vaccines that are specific to devastating diseases in underserved countries. We certainly know this when we spend time in Tanzania, and we all hear about the outbreaks of Ebola that have happened in Uganda and Congo, and of course in Western Africa several years ago. But these are significant diseases that cause significant illness in individuals, and they can come here. We just had our first 2 native-born malaria cases in Texas. This will probably become more of a problem as mosquitoes that can carry malaria, Anopheline mosquitoes, become more problematic with global warming and a lot of moisture and all the flooding we've had. Same thing with dengue. That's an Aedes mosquito. The vaccine has still been kind of hard to come by for dengue, but it is being worked on. I think the mRNA technology might be helpful for this. And that's really been a step forward in terms of fighting 3 very significant diseases. We do now have a malaria vaccine for children. We need to sort of tune that up a little bit, but it is highly effective in very young children preventing severe disease. Vaccines can be used as therapy. I mentioned the vaccines being used to treat Ebola after individuals have been infected. And that was a huge observation, very important one, development that happened in Western Africa. Vaccines, of course, can be used as treatment in cancer. Very interesting papers that have been coming out using the mRNA technology to treat pancreatic cancer. And so I think that the utility of vaccines throughout medicine is going to be really important. And we have to continue to study how we can use them and what kind of long-term benefits that they can elicit for individuals and protect them from other diseases. And finally, this is a paper that was just accepted in July of 23. Very interesting paper, very well done. Although it was a retrospective cohort study, looked back at individuals 65 years and older, was a 2-year look back and an 8-year follow-up, and they discovered a statistically significant difference in the emergence of Alzheimer's in patients who'd received a wide variety of vaccines, the Tdap vaccine, the herpes varicella vaccine, shingles vaccine, or the pneumococcal vaccine, that unvaccinated individuals had a slightly higher incidence of Alzheimer's than individuals that had been vaccinated, not necessarily for all 3 of these, but it received at least one of these vaccines. And these were quite large studies with thousands of patients. Something we need to look into more. The etiology of Alzheimer's is still not clear. It does probably have some sort of inflammatory a component to it, and it's thought that vaccinated individuals, their immune systems are a little bit more revved up and kind of on alert, and maybe there will be some really nice benefit from protecting you against a very severe cause of dementia. So this is more to come on this, but a very, very interesting study that was kind of the first of its kind. Finally, I just want to sort of try to talk a little bit about how we prevent the problems that we encounter in infectious diseases. Many of you know now that we have entered the era of Anthropocene or Anthropocene. It's a hard one to say. We came out of Holocene, and now we're in Anthropocene. And that's because since 1950, the presence of human beings on the planet has had the most significant impact on the planet. Its climate, its ecosystems, its species, the appearance and disappearance of species. Some of this, may have been natural, but a lot of it is due to our own presence here. And so I think in order to prevent more pandemics, to prevent more zoonotic infections, to prevent the spread of diseases quickly, we need to be vigilant, we need to be transparent, we need to be very protective, and we need to be good stewards of the planet because we want to not become the pathogens of the planet. We want to become the immune system. We want to be the T and B cells that protect the planet and pass it on to our next generations in a healthier way. So with that, I'm going to conclude. These are my references, and I'd be happy to take some questions. If you're still there and still awake.
Still awake.
Katrina.
Hi, Dr. Shriner. Thanks for the very interesting lecture. Question about the timing you would recommend between getting the influenza vaccine and the COVID booster for this coming year.
Yeah, you can get them together. I've always been sort of a proponent of spacing them out a little bit, just because, that's a lot for your immune system. Oh my gosh, I just got SARS-CoV-2. No, I just got influenza. If you're in dire straits and you're heading off someplace and you need to get both, you can. But giving people multiple vaccines of multiple different things, it can be sort of unpleasant for them. It doesn't really have any super deleterious effects. I usually recommend you space it out by a week or two. In California, our flu season tends to be later than the East Coast. We kind of peak usually in February because our climate is warmer and people are not as indoors as much. But everything's sort of topsy-turvy now in terms of the weather. So, and we've had already an uptick in COVID. So I would say that the influenza season could be a little brisk. So, just space them out. If you want to wait till XBB comes out and then you wait a week after that, that's probably fine. My understanding is that it's going to be widely available and you don't have to, there shouldn't be a shortage of it because 3 manufacturers are making it. So you can do it at the same time. I wouldn't do it in the same arm, but just because you have to drive home. But I think spacing it out a little bit, it's a little bit more sensible.
Thank you. One other question for the Tdap vaccine. If you can't remember exactly when you last received it, what's the safety regarding getting the next one, not wanting to get it too soon?
Well, if you roll into any emergency room after some sort of injury, you're going to get a tetanus shot. Maybe if you had been in an emergency room 2 weeks before and you got a tetanus shot. It's a pretty safe vaccine. It's a toxoid vaccine. So if you can't remember when you got it, then you're probably at least a year or two out. It does last for a long time. That's why you probably don't need it more than 10 years. But it's not going to hurt you if you get them a little bit closer together. That's not going to be a problem.
All right. Thank you so much.
You're welcome. Other questions? Any other ones in the chat? Yeah, I appreciate that, Mary. Yes, we want people to get motivated to get vaccinated. It's a good thing. It's a very good thing. Well, I would encourage all of you to stay healthy, get vaccinated if you can. when it's available. And if you're interested in hearing about snake venom next week, please attend our lecture with Dr. Texas. It should be really good. I'm particularly interested in snake venom, actually. Also, if you're in local and you'd like to come to our Harvest Festival, we'd welcome you there, and I think it'll be a very nice event. So you can register at Phil Simon Clinic, Tanzania, and I think the connections here are on the chat room. So
Thank you very much, Kim.
thanks, Mike. Hi, Joey.
Say hi, Dr. Shriner.
Say hi.
Can I say who this is, Stacy?
Of course.
This is Joseph Shriner Nesselhut.
Hi, Dr. Shriner.
Hi, Joey.